Universal Time.
I am in radio contact.
Today in the lab, it is yet another L7805CV video. So we are starting with a fresh box from Mouser, and how do we know it's from Mouser? Well, it says on the shipping label, it's from Microelectronics, and also Mouser uses these awful one-time non-resealable boxes for some reason, which are fairly annoying, because you can't use a box you get from them for any other purpose once you receive it. So they have these pull here to open tabs. So I guess it makes it easier for them to close on their end, but kind of annoying on my end. Alright, let's see what's in the box that FedEx brought. That's a new one. So not only that, apparently they're collapsible as well. Okay. Bag is out of the box. I also ordered some other stuff because I got a few projects going on. So let's see what's in there. So in the last episode, we've determined, actually the last couple of episodes on the L7805CV, I've determined that I can't trust my stock that I got from eBay back in the day, and everyone's like, well, a lot of people in the comments are like, well, that's what you get for buying from eBay. Like, what do you expect, eBay from China? So, good point. So, there they are. So these should be genuine L7805CVs purchased direct from Mouser. And I ordered 25 of them to replace my on-hand supply. So here's the hilarious thing about this. While I was searching on Mouser's website for the L7805CV, it presented me with 3 choices. So on the list, the top 2 choices are legit ST Electronics parts. So we have the L7805CV that I've ordered, the L7805CV-DG, which the DG version means that it has a double thickness mounting tab. But to show that you can in fact receive a counterfeit part from a legitimate source, this is an L7805CV that is provided to Microelectronics from Adafruit. And according to the description here, it is rated at 5 volts, 1.5 amps. So let's see what is in that package. And here is the Adafruit packaging. And inside the Adafruit packaging, alright, so taking a closer look at our regulators, we have the Adafruit supplied L7805CV on the left, and the genuine ST L7805CV on the right. So at first glance, they look pretty much the same, but we can see that the part on the left definitely has a different, more rounded font. The ST logo is slightly different in the lower left corner, The dimple to the right of the logo, it actually has like a stamping in the plastic on the genuine part, which is not there on the questionable one. And there's a few differences. The tab looks just about almost the same, and the thick part of the leads is a little bit different between the questionable part and the known good part. Okay, to address comments that people have left in our previous videos, a bunch of people have said, hey, why don't you put a voltmeter on the input terminals to compensate for the wires coming from the power supply? Well, what a good idea that is. So we'll be monitoring our input voltage on this Fluke 73 Mark III. Some people have also commented that I do not have capacitors, and that's why these regulators are failing my testing. I do in fact have two tantalum capacitors on the test jig, one on the input and one on the output. They are 10 microfarad and I believe 25 volt rated. And this is our new Wakefield heatsink, which I drilled a hole through and mounted the regulator with a nut and a bolt. I was going to just press it on there with some heatsink grease, but I do have a secure mounting hole, and for today we are using GC Type 44 extra high efficiency heat transfer compound. And also, for you people asking about the test jig, I will put the schematic on the screen. As in all the previous episodes, it's really simple. It's two capacitors, one on the input, one on the output, and 6 jumpers feeding into 6 20 ohm resistors. So for each 20 ohm resistor that is switched in, it represents 250 milliamps worth of load on the regulator. Okay, so first up in the test jig is the Mauser part number 485-2164, which is a supplied by Adafruit part. Their manufacturer part number 2164, but it is a marked L7805CV regulator. And if you go to the Adafruit website, it says as much and also supplies you with an ST datasheet. Okay, so let's start with the testing. I have 7.01 volts reading on the input of the regulator, getting 5.07 out, so a little bit off of 5.00, but not too bad. We can work with that. 68 degrees, which is very close to room temperature right now. 20.3 Celsius. So starting with the first load jumper. Now reading 251 milliamps on the benchtop power supply. We're getting a little bit of twitching on our Fluke 73, but I'm not going to worry about it. No change in output voltage. Second jumper in. 6.98 volts. Still not going to mess with it. We are reading 485 milliamps on the benchtop supply. Our output voltage has dropped to 4.94 volts. And with the third jumper, starting to see a slight temperature rise on the thermometer. Okay, third jumper in. These are actually doing pretty good compared to the ones that I got in the previous videos. So we're actually reading 689 milliamps on the bench power supply, but we have fallen to 4.72 volts on our output. And with 1 amp of load switched in, we have fallen to 4.5 volts, reading 6.95 on our input meter. switching in the 1 1/4 amp jumper. Okay, with 1.25 amps of load switched in. The benchtop supply is showing me a load of 1.045 amperes. Our input voltage is still very close to 7.00, but our output has fallen to 4.3, and about 77 degrees on the regulator. The case is, I can't even notice any heat on my fingertip, but the case temperature is rising slightly according to our thermometer. And I will switch in the last jumper. Oop, missed it. Okay, and with our 1.5 amps worth of load switched in, our input voltage has fallen to 6.93, but our output voltage is now 4.00. So this regulator actually performs very well compared to the ones that I had on the previous episodes. Actually, not too shabby compared to what we were seeing previously. So I will dial, so now that I've got like the last load switched in for our 1.5 amps worth of load, our power supply, our benchtop power supply, is showing a load of 1.17. So very more betterer compared to the previous regulators. But I will dial this up to 7.0 on the dot, just so we can see what that does to our output. So our output voltage came up a little bit, but we're still down from the stated 5 volts. So just for kicks and giggles, I'm gonna run it up. So here's 8 volts with an 1.5 amp load, and I'm only showing 4.1 volts on the output. Okay, so it's taking a couple of minutes for our thermometer to come back down, but this go around we're still using the Adafruit supplied L7805CV. But I have the power supply dialed up to 8 volts. So starting with resistor number 1, we have a 0.02 volt drop on our input. Still solid on output meter. So 500 milliamps worth of load. Just a little bit more drop. No change in output. Yeah, drop that one. Okay, so 3/4 of an amp switching in. We are down 0.05 volts on our input due to the resistance in the cables coming from the power supply. No change in output voltage. So at 750 milliamps, the benchtop supply is actually reading 740 milliamps with the 3 jumpers. Jumper number 4 for 1 amp of load. Actually pretty solid. Still showing 5.07 volts on the output rail. Pretty good. So now with 1.25 amps switched in, we're down 1/10 of a volt on the input. Our output is showing 4.96 now, so we've came down a little over 1/10 of a volt, getting a rapid rise on our temperature. Benchtop supply is showing about 1.2 amps of load right now. And with our last jumper switched in, okay, with our last jumper switched in, we didn't quite make it, but we did pretty good. So we're now down to 4.13 volts, and our input voltage is down to 7.91, 7.92 due to the resistance of the cables coming from the power supply. So for amusement purposes, I am just going to dial up the power supply real quick so I get 8.00 on our input meter again. Right there. So we are still down almost a whole volt from where we started with the full 1.5 amps worth of load switched in the test jig. And we are still getting a rise on the temperature meter. But this part is actually really decent compared to the ones that we've seen in the past that we've known have been counterfeit. Okay, we now have our genuine ST L7805CV in the circuit. This is what I got from Mouser. It is their part number 511-L7805CV. Input reading 7.01, output 5.00 on the dot, starting at 76 degrees Fahrenheit. First jumper for 250 milliamps worth of load. Barely any change. Benchtop supply is reading 250 milliamps on the dot. Second jumper. We've seen a little bit of change on the input. Nothing terrible. Still reading 5.0. Benchtop supply at 493 milliamps. Third jumper. Very little change. We've came down 0.01 volt to 4.99. Jumper number 4. 4.94 volts on the output, 6.9 volts input. Jumper 5 for 1.25 amps worth of load. Came down a little bit to 4.84 and 6.92 on the input, and the last jumper for 1.5 amps worth of load. The output voltage is 4.73, reading 6.91 on the input. The benchtop power supply is reading 1.3 amps. So I'm going to dial up that a little bit to get 7.0 on the money on our input. And our output voltage came up to 4.8 volts. So doing pretty good, but we're now going to repeat the test at 8 volts on the input. Okay, we are now on 8 volts input, starting with jumper number 1. Barely any change. Reading a 1/4 amp of load on the benchtop supply. Second jumper for 500 milliamps of load, reading 0.491 amps on the benchtop supply. Seeing a little bit of movement on our voltmeter, but that is the input voltmeter. That is because of the loss of the power supply cables. With 3/4 of an amp switched in, still looking good. No movement on the output, reading 5.00 there. With the 1 amp of load, still reading 5.00 on the output. Benchtop supply reads 968 milliamps. Fifth jumper for 1.25 amps of theoretical load. No movement at all on our output. Benchtop meters reading 1.21 amps. And with our last jumper in, We are reading 1.453 amps on the benchtop supply. We're losing about 1/10 of the volt in the power supply leads, but absolutely no movement on the output. 5.00 on the money. So yeah, you definitely want to make sure when you buy regulators that not only are you buying from a reputable supplier such as DigiKey or Mouser, but that they're buying their stock from a reputable supplier as well, such as the actual manufacturer.